Let's go ahead and get started with Chapter 1, which is a general introduction to Python and programming in general. And here's a list of everything that we're going to be covering in this video. We're going to be talking about what algorithms are. We're going to be talking about some general information about Python. We're going to talk about debugging and syntax errors and runtime errors and all kinds of good stuff that you need to know before we start doing a bunch of coding. So let's go ahead and get started with talking about algorithms and what algorithms are. So an algorithm is a step-by-step list of instructions that we're going to use to produce something. So you can think about this as a cake recipe is an algorithm. It tells you exactly how you're going to produce that cake, right? And we use programming languages to convert an algorithm into a program that can be executed by your computer. We're going to use the Python programming language in this class to execute those algorithms that you're going to come up with. Now, Python is a high-level language, and what we mean by a high-level language is something that can be easily understood more or less by a human being. This is opposed to a low-level language, which is something that is actually run by the computer. So computers, inside their processors, they have what are called instruction sets, and that is basically a list of commands that tell them exactly what to do. So we are going to use high-level languages to write code, and that is then going to be converted into the low-level language that the computer can actually understand. Now, the nice thing about high-level languages is that they are portable. They can run on different computers depending on the languages. Some languages are more easily ported than other languages. So Python, Java, JavaScript are all super easy to port because they have processes that allow them to run on different machines pretty easily. C++ and other languages are a little bit more difficult, where you have to get compilers specifically for the target machine that you want to run the code on. And we'll talk more about what compilers are in a little bit. Actually, right now. There's two ways to process high-level languages into lower-level ones, and that is to either interpret it. Okay, so we're going to take the source code, we're going to read it, we'll talk about more about this in the next slide, or we can compile it. So with interpreters, we're going to take our original plain text, and this is just something you type into Notepad or whatever your Mac equivalent is, or Vim or Nano if you're using Linux. And then we're going to read the source code one line at a time and convert it into an instruction. Interpreters are a little bit slower than compiled programs because it has to check everything on the fly. Whereas compilers, we are going to take our source code and we're going to convert the entire file at once into object code, which is then going to be run by an executor. Basic, Perl, Python, JavaScript, these are all examples of interpreted languages. Compiled languages include C, C++, Visual Basic, and so on. We also have some hybrids like Java and C++, which convert your source code into bytecode, and that bytecode is then interpreted. And if this isn't a class on Java, so we're not going to get into that process at all, but what you need to be aware of is that languages are typically either compiled or they're interpreted. When it comes to actually running a Python program, we can do it in several ways. We can either do it in shell mode, which we run it from the Python prompt. We can do it in program mode, which we're actually executing a file. Or we can also use notebooks, which are really great ways of running Python in little snippets. And so I'm going to show you some examples of all of that. One of the first things that you're going to do as a programmer in any language is that you're going to write a hello world program. Okay, so that's what we're going to do. We're going to write a simple Python program that just says hello world. So I would like you to follow along and make sure that you can do this on your home machine, and either do it on your own device or use the Park virtual desktop to run the code there. And there's guides posted in Canvas on how to do all of this. So if you need help with that, look in the Canvas shell. There's some walkthroughs on how to set up your virtual desktop, so that way maybe you don't have your own computer and you're working from a lab or you're working from the library or whatever. You don't need to install software. You just need to be able to access the virtual desktop. Let's take a look at running this hello world through our command prompt. So here is my command prompt, and if you're on a Windows box, you can get this just by hitting Windows key and R and then typing in CMD, or you can actually search and find the command prompt. There's a number of ways to get it. Just Google it if you're having issues. So to launch the Python shell, all we're going to do is type in Python. And that brings us to our triple arrow Python prompt. This allows us to type in commands that are going to be executed. In this case, our hello world, we're going to type in hello world. And all it's going to do is echo it back. Okay? And that's it. That's hello world, and that's usually the first thing you do when you're starting in a new language. To exit out of the Python shell, you can just type exit with parentheses, and that will leave the Python shell. You can also type help with parentheses to get more information, and you just hit Q to exit the help, and then exit, and that exits the interpreter. Or you can just close the command prompt. I also said you could run this directly. So if we were to take a look at a file that has our Python code in it, here you can see that I have a Python file inside of Visual Studio Code, and I'm going to go over Visual Studio Code in a minute, but it's what I use to edit my Python. But you can see that it's named hello.py, and if I just do a quick search in the directory, I can just do star.py, and you can see that we have a hello.py file there. So from the command prompt, I can just type in Python, whoops, helps if you spell it right, Python hello.py. And there you can see that it prints out hello world. I also mentioned that Jupyter notebooks are a great way to run Python code, and we're not really going to be using them in class, but I just want to cover it real briefly just to show you how you can use them. So here I've opened up a notebook in Visual Studio Code, and you can see that it's a notebook because it has the extension IPYNB, which is Interactive Python Notebook. And so the nice thing about these notebooks is that it allows you to execute code in individual cells. So I can say print hello world like such, and then I can run this block of code and it prints out hello world, and then you can see it opens up another cell block. I can come down here and I can add more code. Let's say 1, 2, 3, right? And I can rerun this cell by itself. And I can come down here and I can do something else. I could say, actually let's just do A equals 1, B equals 2, C equals A plus B, print C. And you can run this code right there, and you can see that it's printing out 1 plus 2, right? Now the nice thing about it is once you run a cell, you can use that cell by itself. So you can say, well, I want to print C plus 4, all right? And you can run that, and you can see it use the value of C from this previous cell. So again, I'm getting a little into the weeds, but Jupyter notebooks are great for these types of things. And so as another example, here's where I used Python. Let me minimize there, make it a little bit smaller. There we go. I used these Jupyter notebooks for my son's science fair project. So the nice thing about the notebooks as well is that you can mix markup text with your actual Python code, so you can kind of make a report. You can talk about what you're doing and then go ahead and do it within the code. So here is just, we're doing an analysis of different types of bubblegum on bubble size. And so we were generating a lot of graphs and charts using Python, and some data science tools to go ahead and analyze all of these different features. So you can see here, this is just an example of kind of the power and the flexibility that you have with Python in using it to conduct scientific experiments. But again, this is just one example. We're not going to be using these in the course, but it's kind of hoping to spark your curiosity and maybe go out and look for additional things that you can do after the class is done. So by this point, I really want you to make sure that you can write a Python file. So it's just open up a text editor and save it as the file name needs to be .py, right? That is absolutely critical that you are able to do this. If you can't do it at this point, stop the video, text me, call me, email me, whatever, and say, hey, Mr. Willinger, I can't do this. And I will walk you through the process. I will help you. We'll set up a Zoom meeting. We'll do whatever we can. But it's absolutely critical that at this point you're able to write a Python file, save it locally, and run it locally through any one of 19 different ways of doing it. Right? I'm not really concerned about how you do it, but I want to make sure that you can, in fact, do it. As we're talking about programs, there's also some terms that we're going to be using. We're going to be throwing them around, so I want to make sure that you know what we're talking about. The first one is going to be input. And basically, that's just getting information from either the keyboard, a file, or some other device. Output, on the other hand, is sending information to the screen or sending it to a file or some other device. We're also going to talk about math and logic. And in this, we're just going to be doing basic mathematical operations. You saw me do an example of adding A and B together in the previous slide. We're also going to be using logical operations like and, or, and not. If you've already taken CS152, you're familiar with these terms, extensively familiar. If you haven't taken those, we're going to cover it. Just be aware that, when the and, or, and not have specific meanings that we're going to be using within conditional expressions. So when we're talking about conditional execution, we're talking about checking for that certain conditions are true or false in order to tell our program to execute certain statements or to not execute certain statements. And we're also going to be talking about repetition, and that means we're going to be doing something over and over again in what's called loops, and we may be changing what's executed with each iteration of the loop. Usually there's some kind of variation with it, but we want to be executing some block of code multiple times, and so that's repetition. As you're programming, you're going to be making lots of mistakes, especially when you're first starting off. But even once you've been doing it for a while, you're still going to be making lots of mistakes. So debugging is the process of tracking down errors in your code and fixing them. Now, there are three primary different types of errors, and those are syntax errors, runtime errors, and semantic errors. And each error has its different ways to find, fix, and test them. Let's take a look more in depth at each of these types of errors. So a syntax error is when you have an error that refers to the rules of the grammar of the language. So when you're writing an essay, a syntax error would be not capitalizing the first letter of a sentence or ending it with punctuation. A syntax error in code can take many different forms depending on the language that you're working with. For example, in C++ and Java, if you don't end a sentence or a statement with a semicolon, that's an error. In Python, if you don't indent correctly, that's going to be an error. Or if you don't use the proper quotes when you're talking about a particular string, right? And we'll talk about what strings are. So the question is then, what would you normally use to find a syntax error? And this depends on the language that you're using. So if you're using an interpreted language, the interpreter itself will find syntax errors because it is looking for certain conditions to exist within the code and you, the programmer, didn't put it there. So the code is not performing as the interpreter is expecting it to. Now, in a compiled language like C++ or Java, the compiler is going to find it when you compile your code. So these are the easiest problems to find because it will give you an error. It will tell you, hey, there's a problem with this line of code. I was expecting this, I didn't see it, and so on and so forth. Let's go ahead and get some practice at finding syntax errors. So the following program is going to have several errors in it. Let's see if we can find what they are. Now, I know you're not a Python programmer professional yet, so I'll go ahead and help. First of all, the first one that's missing is we've got a closing apostrophe or a single quote right here. So this is a string. This is text. And so all text that's in a program has to be enclosed with either a single quotation or a double quotation. So the compiler, or the interpreter in this case, would see this single quote and say, okay, I've got text, and then nothing. It just keeps going. And so it would consider all of this text because we never put in a closing quote. Right? So that's the first error. The next error is the while loop right here. Okay? Now, normally a misspelled word would be a semantic error, but in this case it's a syntax error because it's on a key word. While is a key word within the programming language that means something specific. So this would generate a syntax error. The program, the interpreter, would get to this point of the program and say, I don't know what you're trying to do here because I don't know what this word is. Now, assuming that this is the complete program, the next error would be Z right here, because the program, we've never established what Z is actually equal to, what value is stored in E. So this would also generate a syntax error because it would be like, well, I don't know what Z mod 2 means. We'll talk about what mod means. But this right here would be an error. Okay, on this line, we're missing an opening quotation. So you can see we have a closing quotation. We're missing an opening quotation. And then finally, our last syntax error would be we're missing quotation marks around the print. So just like this one has a quote or a parenthesis right here, opening closing parenthesis, because print is a function, well, you would need it here as well. Runtime errors are those errors that can be found when the program is actually running. And examples of these would be divide by zeros, which you can't do. If we try to access a variable that's not there, okay, or an array index out of bounds, we'll talk about those. Under and overflows. So these aren't necessarily errors that are limited to the Python language, but all programming in general. And these are also known as exceptions. And there's ways that we can handle exceptions in all the different languages, and so we can guard our programs against runtime errors as long as we're coding smartly and defensively. Now, when we're executing our program is when we would normally find it. So in this case, in Python, we would normally find runtime errors through the interpreter, because remember, we're not compiling the program, we're running it one line at a time, so the interpreter is going to find these as well. In a compiled language, the part of the program that's executing the code, so the executor, would be what's finding the program error, or the syntax error, if you will. Let's see what happens when we actually encounter a runtime error. So we're going to take a look at this code, and right now we can tell that it's going to generate a runtime error because we have a hard-coded divide by zero. You should never do this, and your program should guard against this situation from happening because of what you're about to see. So if I open up my code in Visual Studio Code, you can see here that I have the program typed in, and this is running Python code. I'm going to click the little play button up here, and you can see that my program is prompting me to enter a number. Now this doesn't actually matter, so we're executing this input section right here. And so I'm just going to type in a number down here. I'm going to type in 23, and we're going to see what happens. Alright, So you can see that I hit enter, and it came up immediately with this zero division error, division by zero, right? So it will tell you in what file and what line that your error actually is in. So you can go back and look at it and say, oh, okay, so something funky is going on in line 2. So you come up here to line 2 and you go, yep, sure enough, I'm dividing by 0, right? So if I were to change this to, say, 3, right, and we rerun this code, now it's asking me to enter my number again. So in this case, do the same thing, 23, and you can see there that my answer is 7.6666 repeated, right? So that is what a runtime error looks like when you actually execute it in your IDE or other ways. In addition to syntax errors and runtime errors, we also have semantic errors. Semantic errors means it's relating to the meaning of the language. Basically, this is you told the interpreter to do something that you didn't intend it to do, right? So what's an example of that? Well, here's an example right here. Is we are printing 3 plus 5, and it's going to print out 35, but you wanted 8, okay? Because the way that this is written right here, this is a string, and so it's going to do what's called concatenation. It's going to put the two strings together instead of actually doing the addition. Another example of a semantic error is when you don't follow your proper order of operations, or you put something in the wrong parentheses, right? So if we take a look at this section of code right here, you can see that we are trying to, our intention is to add A and B together and divide by 2, but because of your order of operations, we are going to actually divide B by 2 first, and then we're going to add it to A. So this would be an example of a semantic error. The best way for you to find errors as you're learning to code is through experimental debugging, right? And debugging is an extremely important skill to develop, right? You're not going to be, like I said, perfect the first time you code. You're going to have a lot of frustration when you're trying to figure out why things aren't working. So you need to approach it like a science experiment. You know, form a hypothesis in your mind. Why do I think that this isn't working? And then you test that hypothesis. You make a change to the line of code. And then you rerun your program to see if you fixed it. And if it didn't, you change it back and then change something else. So just like in an experiment, you only want to change one thing at a time. All right? So the best approach is to code, test, and debug in small, manageable increments. I can't overstate this enough. I know I'm reading from the slides here, but you really have to do this. You write a little bit of code and execute it. And if there's a problem, you make changes, try to fix it, and then run that small section of code again. And you don't continue writing more code until you fix the problem. So as you're writing code, this is what your expected output is going to be, right? As you progress in time, you're going to expect your program to increase in its functionality the more you go, right? Now, you realize that you're going to make mistakes. So you're like, okay, well, I'm going to have to spend some time fixing my code. So my program's actual functionality as a matter of time is a little bit less than what you expect it to be, right? So this delta, this difference, is your relative debugging effort. So this is what most people kind of expect as they're going along. However, for new programmers, this is what it really looks like. Okay, you are going to be making lots and lots of mistakes, or as I'd like to say in my face-to-face class, this is the crap that has gone really, really wrong, and you have no idea why. And you call me an hour or two before the assignment's due, and then I laugh at you. No, I won't laugh at you, but seriously, you got to start early, and you got to expect that you're going to have a lot of this problems. Okay, you're going to have a lot of errors, and you're going to get to the end, and you're going to be like, My code doesn't work. It's got 57 errors and I have no idea why. That's why you got to do it one bit at a time. So a better approach, and what I've been advocating all along here, is that you make a small change and fix it. Make a small change and then fix it. And so you're going to get this more of this kind of like stair-step graph where you are bringing what's expected back up into line to where your program should be as you go along. And if you do this, you're only fixing minor errors, not these big, huge errors, and so it's much easier to debug as you're doing this. This also could be because you asked for help early, and so you were able to fix it instead of, like I said, making tons of mistakes or mistakes built on other mistakes, built on other mistakes. That's when you really get into trouble. So start early and ask for help early. To close out Chapter 1, let's talk about the difference between formal and natural languages. Natural languages are those things, are the languages that we speak. English, Spanish, French, whatever, right? Formal languages are languages that are designed to be used in a specific application. And they have very specific rules on how they are used and applied. And they have rules about syntax, about tokens, which are how you break up the words in the language, and the structure, how are they arranged within your program. And there are some similarities and difference between these two. So what rules does English have about tokens and structure? Well, let's take a look at some examples, right? So the first example is the dog walked down the street. All right, that's easy to read, easy to understand. What about street the down, dog the walked? Does that make any sense? Or what about this, which is just all the letters are shifted or rearranged? Actually, if you notice, if you're good at cryptography, you'll notice that all I did was shift all the letters one letter to the right. So T became U, H became I, E became F, so on and so forth, right? But just that one letter shift makes this sentence unreadable. Okay? Or here's the same thing. Street the dog, down the walked, shifted one letter. You can't read it. It's nonsense, right? So obviously, which of these are easy to parse? Well, that's going to be the first one because it's proper quote-unquote code. The second one has structure issues, right? We've rearranged the structure of the program and it no longer makes sense. The third one has token issues because we've shifted all the letters. And the last one has token and structure issues because now it's just a hot mess, is all it is. How are formal and natural languages the same, and how are they different? Well, they both have tokens and structure and syntax and semantics, the things that we've already covered on the previous slides, right? Well, they're different in the way that natural languages tend to have more ambiguity in them, right? People use context clues and body language to suss out the meanings when there's ambiguity present, where formal languages are designed to mean exactly what they say. As a result of that, natural languages also are more redundant, and formal languages tend to be more concise. Formal languages are also very literal. What they say is exactly what they mean, and natural languages tend to use idioms and metaphors and things where, when they're taken out of context, they lose their meaning. And in natural languages, we also have poetry and prose. The way that we write and the words that we choose are often more important than the actual words themselves because of the way that they sound and things like that. So that's some of the differences and similarities between formal and natural languages. So why are we talking about natural language when we're in a programming class? Well, because you're going to be using natural language as a part of explaining your code, right? And that's what code comments are. They're an essential part of programming. And you use natural language in your comments to explain what your code does, but not how it does it, because how it does it is written already within the code. So comments are not evaluated by the interpreter. They are purely there for you, the human, to read and to add additional context to the code. And Each language has its own way of writing comments. Some are more similar than others, like Java and C++ are very similar. But Python has two types of comments. We have a single line, which starts with the # or hashtag for you youngins. And then there's also a multi-line comment that starts with a triple single quote or a triple regular quote, right? So this is what an example would look like. So here's a single line comment. You can see that in green right here, and you can see this multi-line comment with triple single quotes, and you can also see a multi-line comment with triple quotes. Now, the only thing that you have to be aware of is that if you start with the triple single quotes or the apostrophes, you need to make sure that you end with the same type. Right? So you can do either one of these. Also, in your program, don't mix and match. If you're going to be using single quotes for a multi-line comment, then use that throughout your entire program for multi-line comments. This statement right here is not a comment because it's an actual part of a function, and so this is what we would call a string, or a string literal. So as a final exercise for this chapter, let's go ahead and add comments to our Hello World program. So if I jump over to Visual Studio Code, you can see here I've got my Hello World. Well, let's add some context. All right, so we're going to add a multi-line comment. I'm just going to paste it in here. So you can see that I have a file name. I have a description telling you what it is, right? I have the author, myself, and a million people before me, probably more of that. And then the date that it was last modified. So in this case, I'm going to update it to now, which is going to be, we are August 6th, 2020, right? And then hello world. Now a single line comment would just be, you start with the hashtag or # and you say, this will print hello world. So you can see here that this comment doesn't really add much to the program. So this would typically be unnecessary because I can see right here that this will print hello world. But this is just to demonstrate how you would do a single line comment versus a multi-line comment. So that wraps up Chapter 1. If you have any questions, please reach out to me. Again, make sure that you can get your development environment up and running in short order. It's critical that you get that working. I've had students that got into week 3 and still didn't know how to run Python code on their personal computer. So please make sure you get that done. And if you have any questions on the rest of the material, please reach out and ask for help. And that's it.